Haptic feedback for AR and VR mostly exists as simple handheld controllers or complex glove systems, both which burden the hands. Alternatively, it may be possible to relocate haptic feedback to the wrist for a variety of virtual hand interactions. To explore this, we built Tasbi, a haptic bracelet that vibrates in 6 locations and provides uniform squeeze pressure. Vibrations are rendered through 6 linear resonant actuators, and squeeze is accomplished through a novel tensioning system that affords Tasbi high force output in a small package size. Our approach to creating believable interactions has 3 parts. First, haptic vibrations render discrete events such as hand collisions, impacts, and high-frequency content. Second, we use proportional squeeze for continuous forces such as object stiffness, weight, and inertia. Finally, visual pseudo-haptic effects manipulate the virtual hand position to give the illusion that certain actions require more physical effort. Let's take a look at some examples. In this button interaction, vibration is rendered when the user contacts the button's surface and fully depresses it. Squeeze increases as the button is pressed to convey a spring stiffness. In fact, by increasing the rate of squeeze and the intensity of the pseudo-haptic effect together, it is possible to make buttons that feel harder to press. Vibration, squeeze, and visual pseudo-haptics can be applied to other motions such as pulling and twisting. Subtle vibrations can be rendered on top of squeeze for added effect and realism. It is also possible to render surfaces with Tasbi. Vibration can be used in a conventional manner to render fine detail surfaces and textures. Squeeze can convey more coarse surfaces with actual geometric depth. Both effects complement each other well when combined. The sense of mass can be conveyed by applying a proportional amount of squeeze when objects are picked up. The amount of pressure can be altered to suggest changes in the center of mass. When players wave objects in the air, their inertial properties can be rendered through small fluctuations in squeeze. Tasbi can also enhance locomotion in VR. In this latter example, vibrations are rendered when the player grabs each rung, with squeeze increasing as they pull themselves up. This gives the overall impression of climbing. Tasbi is most compelling when haptic feedback is provided on both hands. This is especially true for two-handed interactions that simulate reactive forces between the hands, such as this bow and arrow example. This pistol represents a more complex example. One-handed effects such as squeeze for trigger pull and vibration for firing are present. Two-handed effects are felt when the player twists off the silencer or pulls back the slide of the pistol to reload. Overall, these early explorations with Tasbi suggest promising potential for simple wrist-based haptic feedback.